Hey everyone, I'm Paul, and I make poor choices when I fix my car. In the next few RAV4 videos, I'll be undoing my bad fixes. Today, I'm replacing the exhaust manifold and downpipe and the radiator cooling fans. Do you guys hear that? That's the sound of the exhaust flex pipe leaking. This stupid pipe is broken, for the third time. The other problem is I made this exhaust manifold from an aftermarket manifold / catalytic converter for a Camry. Notice it doesn't have a heat shield. It wasn't a big deal until I drove my car on a 100-degree day and everything in the engine bay got scorching hot and my fancy expensive cooling fans melted. Now, did they short out because the manifold was too hot? Maybe. Are they worse quality than the original Toyota fans? Probably. Let's start under the car and unbolt the exhaust downpipe from the pipe in the middle of the car. That gasket is the Felpro 23626. The 1997 and earlier RAV4s have 3 bolts holding the Down syndrome pipe onto the catalytic converter. This pipe is pretty special. You always have to finagle the pipe out of its spot above the subframe. I hate flex pipes. What a stupid thing. I'll be taking the alternator out of the car, so the next step is disconnecting the battery. Now I can take the big terminal off the alternator without shorting it to the case. Loosen the alternator adjuster bolt, then take the lower bolt completely out. Use a 14mm wrench on the big alternator pivot bolt, then pull it out. Let's get the wiring harness out of the way, starting with the crankshaft position sensor connector. Unplug the AC compressor clutch connector, then pull the harness up and out of the way. Now the alternator is ready to come out of the car. Notice I'm loosening the exhaust manifold nuts by hand and not using my impact driver. I don't want to unscrew the studs from the head because it's annoying to put them back in. The studs are more likely to stay in place if I don't use power tools here. The earlier RAV4s had both oxygen sensors in the engine bay in front of the engine because this big thing is a catalytic converter. I'll need a little extra room to reach the upper radiator fan bolts, so I'm loosening the mounts for the AC condenser and the radiator. With the brackets off, I can move the radiator forward about an inch. I modified my hood latch support too. This piece is actually good. It's easier to remove than the stock piece. When I installed the flex-a-lite fans, I made these custom blue brackets. They bolt onto the stock mounting locations on the radiator. Let's unplug both fans, then move on to the top mounting bolts. 2 bolts are easy to see, and the third bolt is hidden behind the radiator cap. Okay, now let's pull my almost new, but broken, fancy aftermarket fans out. They're both shorted out. This one spins, and the other one is extra melted. These fans belong in the junk pile. I had to break the mounting tab off the junkyard fan, so I replaced it with this aluminum bracket. Let's test the resistance of the new-to-me fans. My multimeter leads have a resistance of 0.2 ohms. Setting the meter to relative mode is like hitting tare on a scale. The resistance of this fan motor is 1.6 ohms. Now let's test the air conditioning fan. This one reads 12.6 ohms. Getting these fans into the car is pretty annoying, so always test the junkyard parts before you install them. This fan works great. And the AC fan is nice too. These fans are 23 years old with probably 200,000 miles, and they work a lot better than those brand new flex-a-lite fans. Insert the big fan first. Tip the corner under the radiator hose and AC line. Then slide the fan past the clutch slave cylinder. Be careful not to drag the fan against the radiator. Climb under the car and slide the fan over until the mounting tabs line up. Above the car, pull the radiator forward and thread the 2 mounting bolts into the cooling fan brackets. Don't tighten them all the way yet. Install both bolts under the car. Use a shallow 10mm socket. Once all the bolts are threaded in, you can go back and tighten all of them. Push the big AC hose toward the engine and slide the fan down between the hose and upper radiator support. Push the upper corner into place. There is only one mounting tab at the top of the AC fan. Line it up and thread the bolt in. There are two mounting bolts at the bottom of the AC fan. Tighten both bolts, then go back and tighten the top bolt. Now I can reinstall my hood latch support. This is just a piece of angle iron with a couple holes, but the bolts are easy to reach, unlike the stock piece. Add dielectric grease to the connectors if they're hard to plug back in. Okay, with the aftermarket garbage fans out of my car and the reliable Toyota fans back in, I can reinstall the radiator and condenser brackets. I had to pick up new cooling fan fuses from the junkyard because the flex-a-lite fans shorted out. Each fan takes a 30 amp fuse. This is the exhaust from a 1999 RAV4. You get a nice 4-into-1 header that isn't made from a heavy lump of cast iron. Notice there is no catalytic converter here. That goes under the car. My RAV4 takes a total of 4 Felpro 23626 exhaust gaskets. They're available at your local auto parts store. The Bosch 12105 is the upstream O2 sensor for the 1997 RAV4 with California emissions. It's a 2-wire, non-heated sensor. I bought the steel exhaust manifold gasket from toyotapartsdeal.com. Now I can install the manifold and torque the nuts to 35 foot-pounds. I'm using the Harbor Freight Quinn digital torque wrench. Gently apply pressure until the wrench gives you a solid tone. Check each nut at least twice. I got the exhaust manifold and heat shield sandblasted, then painted them with high-temperature exhaust paint. If you've watched my previous RAV4 videos, you know my car had a big problem with rust. I only have one oxygen sensor in the engine bay now. It's the upstream O2. Notice it has a 2-wire connector. I removed my downstream sensor. And if you compare these two, the downstream connector is slightly bigger. Let's go ahead and plug that in. Okay, now what about this connector? I got another connector from the junkyard. I'm just going to plug this in here to keep dirt out of that connector. I'll leave these wires. I'm going to come back to that just a little bit later. The exhaust manifold also has a support bracket to prevent the exhaust system from pulling on the head studs when the engine rocks back and forth. Okay, it's time to put the alternator back in. Tuck it under the AC hose and put it into the bracket. Install the long pivot bolt. Get the belt on the pulley, then thread the adjuster bracket bolt into the alternator. Leave it loose so you can adjust the belt tension. Tighten the adjuster bolt until you get about ½ an inch of up and down movement on the long part of the belt. Always do the final tightening by hand. You have no way of knowing how tight the power tools go. Let's stop for a moment and talk about this Tekton ratcheting wrench. This tool is ideal for working on the hard-to-reach bolts on the drive belt side of the engine. Buy this wrench to make your life a lot easier. Use the link in the video description below. Remember to tighten the alternator adjuster bracket bolt under the alternator. Connect the main charging cable to the alternator, then plug in the big connector. Route the wiring harness over the alternator, plug in the crank position sensor, and the AC compressor clutch. The downpipe from the 1999 RAV4 doesn't have a flex pipe. That's awesome. Hold the donut-shaped gasket in place while you put the pipe up here. I bought new bolts from Toyota Parts Deal and cleaned up the old springs. The bolts go all the way through the downpipe and only the springs actually hold the pipe. This pipe is designed to be able to move.
And it looks like the exhaust flange does line up, thank God. But first, we have to add an oxygen sensor back here.
I'm removing the catalytic converter from the middle of my car so I can work on it. A little lube makes it easier to pull the exhaust out of the rubber hanger. So if we take a look inside here, this is also a catalytic converter. My RAV4 had 2 of them,
Because California emissions.
I got this oxygen sensor bung on Amazon. It includes a plug, and you just weld it onto your exhaust. Clean it up and check the threads with an old oxygen sensor. They're still good. This sensor isn't directly in the exhaust stream. I hope this works. Add some copper anti-seize to the sensor threads. This is the 4-wire upstream sensor for the 99 RAV4. It has the same connector as the downstream sensor and the threaded mounting that I need. So I installed the pipe and... ooh, that's not going to work. The sensor hits the body. A few inches farther back, there's a cutout in the heat shield, a threaded hole for a bracket, and a hole in the floor. I am a fool. Okay, I plugged the bung hole and welded another one in the right place this time. The O2 sensor bracket and rubber grommet are from a 99 RAV4. Now I just need to connect this wiring to the computer over there using the wiring from the 99 RAV4. Let's take a break for a quick overview of my new exhaust system. The manifold is from the 1999 RAV4, and so is the downpipe without a stupid leaky flex pipe. This catalytic converter is the Walker 53416. It fits perfectly and I have no complaints. The rest of the exhaust is stock from my 1997 RAV4. This is the original muffler, but I modified the tailpipe to clear the hitch. To figure out the wiring, I'll need some diagrams. I'm going to eManualonline to see what they have. I'm getting the manual for the 1997 Toyota RAV4. Use the code LabCodePaul at checkout to get 15% off. You'll get factory service manuals in PDF format. This is a download and not a subscription. That's awesome. I also downloaded the manual for the 1999 RAV4. It looks like they're exactly the same. They give you a whole bunch of stuff. Let's go back and look at the electrical diagrams. These also look the same. Okay, what's this one? These diagrams are for the ACA20 RAV4. That's the XA20. These wiring diagrams are for the second generation RAV4. That car has a different engine and the wiring will be very different from mine. How about this other PDF? I don't see a title page. Let's scroll down and see if we can figure out what this is. It looks like these guys just scanned in a bunch of factory service manuals. Okay, and here we have the 1AZFE engine wiring diagram. That's also the second gen. Alright, what about this other PDF? That says 1999 RAV4. Okay, and the other one is also 99 RAV4. They didn't give me the wiring diagrams for my 1997 RAV4. The engine control wiring is very different between the earlier models, 1997 and earlier, and the later models, 1998 and newer. Toyota changed the entire exhaust system, went from 2-wire non-heated oxygen sensors to 4-wire heated sensors, installed different headlights, and made many other changes to the RAV4 in the mid-generation update. Okay, and here is the diagram I need for my new oxygen sensor. I found the 1997 wiring diagrams elsewhere. Now let's figure out what I need to do. Right now we're looking at the oxygen sensor wiring diagram for the 1997 RAV4. Let's shift our focus to only the oxygen sensor wiring. This oxygen sensor is a simple, non-heated sensor with 2 wires. The signal wire goes straight to the computer, and the ground wire goes in a bit of a circle through a junction box and to ground. This diagram is hard to read like this, so let me simplify it. Okay, the black wire is the signal, and it connects to pin 5 on terminal E5 on the ECM. The sensor wire is shielded. That means it has a layer of aluminum foil around the wire that conducts electromagnetic interference, then grounds it so it doesn't get into the signal wire. The brown wire also connects to ground. Now let's look at the wiring for the 1999 RAV4. There's a lot more going on here. The biggest difference is the car has 4-wire O2 sensors. Let's focus on only the downstream oxygen sensor wiring. That's still a lot of stuff. Just like the 97 RAV4, the signal goes to the computer, the wire is shielded, and there's a ground. This sensor has 2 extra wires for the heater circuit. Oxygen sensors don't work until they've reached 500 degrees Fahrenheit. The small built-in heater circuit helps them reach operating temperature faster, which gives the computer more precise control of the air-to-fuel ratio and cleaner emissions. The heater power wire goes to the fuel pump relay and gets its power from the fuel injection relay. The computer provides the ground for the heater circuit. I know you can't see these tiny wires. Let's simplify the diagram. The red wire sends the computer a signal on pin 5 of terminal 5. That's the same place as on the 97 RAV4. We just need to give the heater some power on the black and red wire and just connect the rest of the wires to ground. No big deal. Before I get back into the car, let's talk about the connectors. The ECM connectors are named E4, E5, and E6. The small one in the middle plugs directly into the computer and has the oxygen sensor signal wire on pin 5. The sensor is grounded somewhere else. O2 sensor wiring does not go through the IG1 and IG2 connectors located above and to the right of the ECM. On the 1999 RAV4, the setup is a bit more complicated. The downstream O2 sensor is in the middle of the car, so its wires are not in the engine wiring harness. They're coming out from under the passenger seat, so the signal wire goes through the dark gray IG2 connector before it makes its way to the E5 connector on the computer. The heater ground is routed through the IG1 connector, and there are some shield and ground wire shenanigans going on too. I pulled the oxygen sensor wiring from a 1999 RAV4, and I'll be installing it into my car. It has a total of 5 wires. Let's get familiar with the connectors. The white one is ignition 1 and has 12 pins. The gray one is ignition 2 and has 19 pins. The engine control module, or ECM, has 3 connectors. The farthest on the left is named E4 and has 26 pins. The small one in the middle is named E5 and has 16 pins. E4 and E5 go out to the engine. The last one is a 22-pin connector named E6 and goes to the body wiring. The signal from the downstream O2 sensor goes through this red wire, through the ignition 2 connector, then to the computer. The other wire is a ground for the shielding on the sensor wire. The oxygen sensor ground is a brown wire, and it gets connected to the body ground here in the middle of the dash. Then we have 2 wires for the sensor heater circuit. The black and red wire gets 12-volt power from the fuel injection relay and connects to the wiring harness under the dash. The O2 heater normally gets its ground from the ECM. The red and white wire goes through the white ignition 1 connector before it goes to the computer. It's not very important for the computer to turn the heater on and off. I can just connect this wire straight to ground and the heater will be on all the time whenever the engine is running. Let's start with the battery connected and the key in the on position. I have my multimeter set to volts DC and grounded to the dash here. The ignition 1 connector has a thin black and red wire right there. Let's see if it has power. Yes, it does. It's off in accessory and off when the key is off. This is exactly what the O2 sensor heater needs. I'm prying the terminal lock open with a safety pin. Each terminal is also held in by a little tab. With the tab released, you can slide the terminals out. I'm sliding a piece of heat shrink over the wire to cover my soldered spliced connection. Just snap the terminal back into the same hole and lock the connector. Notice the red signal wire goes through the ignition 2 connector in the newer RAV4, but mine just has an empty slot. Let's pull the terminal out of this connector. Pry the white terminal lock up with a safety pin, then pry the locking tab away from the terminal to release it. Got it. Now it needs to go into my ignition 2 connector. Unlock the white piece, push the wire into the empty slot until it clicks, lock the connector. I've prepared a jumper wire to get the signal to the computer. It will plug into the other side of the ignition 2 connector. Use the safety pin to unlock the white terminal holder. Now I can insert the terminal into the blank slot. Lock the connector and plug it in. The other end should go into pin 5 in connector E5 right there. Let's go to the engine bay. The brown wire on the downstream O2 sensor has continuity to ground. The black wire is the signal. I'm connecting it to this long jumper wire that I'm running into the car so I can test for continuity. I connected the engine side of the red lead to my multimeter, and yes, it has continuity to pin 5 on connector E5. Let's unlock the connector, then use the safety pin to release the black wire from terminal 5. I inserted my new signal wire into the same slot instead. I'll just fold the old oxygen sensor signal wire back and tape it out of the way. Okay, that part is done. I'm using this extra O2 sensor connector as a plug to keep dirt out in the engine bay. We're left with the brown ground wire, the red and white heater ground, and the signal shielding ground. They can all go straight to ground. I soldered all 3 wires to a connector, and they'll just go to this main dashboard ground here. I cleaned up my oxygen sensor wiring and plugged everything in. You really can't tell I was in here monkeying around with the wiring. Now let's test it. Start the engine and connect a scan tool. I'm using the eDiag YA-101. It's cheap and basic and works great. The check engine light is off. I want to look at the data stream. Let's scroll down until we see the oxygen sensors. Bank 1 sensor 1 doesn't work yet because it's the non-heated upstream sensor. The downstream sensor I just hooked up is already working because it has a heater circuit built in. The voltage should change at least once per second. High voltage means rich, and low voltage means lean. I'm revving the engine to heat it up a little. I want my non-heated upstream sensor to start working. It took about 3 minutes, and now both oxygen sensors are cycling at least once per second. Great. If I go back, it says the engine is now in closed loop operation. That means all the sensors are working. I drove my RAV4 a little bit, and it definitely sounds better without a leaky exhaust pipe, and it even felt a little bit faster. Now, I don't know if that's true because I didn't measure the acceleration before and after, but it would make sense that pushing the exhaust through 1 catalytic converter instead of 2 would give you slightly better performance. But more importantly, I got those junky fans out of here, I got that weird exhaust manifold out of here, and I installed original Toyota parts. Now, I've never been an original parts snob, but you know what? You guys might be onto something. The original parts are better. Now, I do have one major problem left in this car that is caused by non-Toyota parts. Let's play the guessing game and see if you can figure out what my next video is about. Clue number 1. Whenever I put my car into gear or shift aggressively, it clunks really bad. Clue number 2. When I replaced the suspension, I also changed some of the drivetrain components from Toyota parts to cheap parts from AutoZone. Leave a comment below if you think you know what it is. That's all for now, and I'll see you guys next time.